Alright, this is the recording for the Systems of Equations, Solving Systems of Equation Word Problems, Part 2. What I have got here right now is the answers and the setups for the problems for Part 1, which were the number problems, perimeter problems, and age problems. Pause it at each section. I'll stop for a couple of seconds. You can pause it, get the answers down, and then move on if you'd like. So there's, like I said, there's problems 2 through, I believe that's 6. Then you can see here problems 6 through 10. And again, pause it here, and then you can always hit play for the next one. This right here is the perimeter problems. You can see this is problems 2 through 6 that you can see completely. There is a little bit of 7, but you can see. And then finally here 7 through 10 for those problems. You can see those. And here are the age problems 2 through 7. There is a bit of a difference in the way the setup's been because of the way they were worded. 2 through 4 I think were the most difficult. 5 through 7 or 5 through 10 became a lot easier to set up and solve. And then finally there's 7 through 10 right there. Okay, so what we're looking at here is now the money problems. And what we'll do with this is we want to decide what is x and y. So if you read the problem on number 2, you can follow along, pause and just read the problem. But I would say here x is the small paper clips and y is the large paper clips. So actually how many boxes I have of each. So the first equation goes with the first sentence. 4 boxes of small, which would be 4x, plus 9 large y would equal 1575. 8 boxes of the small, 8x, plus 7y, large ones, cost 1665. And there you've got it set up, and now it's ready to solve. I mean, you've pretty much got that set up. All you got to do is solve. So solving it might be something like this. This right here should be the inverse method, where I've got the coefficients raised to the -1 power times what they were equal to, and then press enter to solve that. What was on there next was just something that somebody else had written or had asked a question about, so don't worry about that on the bottom. Just worry about what's on top. The 4987 raised to the -1 times 1575 over 1665. I believe that will give you an answer of like 0.9 and 135. So the small box were 90 cents and the large box was $1.35. Okay, next would be mixture problems. Mixture problems deal with obviously mixing something. Now there's 2 types of equations on mixture problems. The first one is the total equation. That makes it super easy because all you got to do is say x plus y equals the total. That's it. Every single time it's x plus y equals the total. There's never a number in front of the x's and y's. Then you get a mixed problem. The mixed problem will have, like, say something, a number times the x plus a number times the y will equal something times the total. Okay, so every single time the total equation will be x plus y equals the total, and then there will be a mixed equation. So for example, if you look on the mixed one, we're talking here with number 2 with the peanuts and cashews. I'm going to say the peanuts are the x and the cashews are the y. So I am going to automatically write x plus y equals the total. And in this case the total is 35 pounds. Then I will write the mixture problem. How much were the peanuts worth? They were worth $2.25. How much were the cashews worth? They were worth $3.25. How much was the mixture worth? It was worth the $2.65, but I would multiply that to the 35. So you see here how I have a total and I have a mixture, one where I actually do some multiplication. And you can actually type that in like that, where you would do like 1, 225, 325, and then 35 and 265 times 35 as part of the matrix. Compare that to the mixture or the chemical one, which is like number 5. I'm going to say x is the 12% brine solution and y is the 16% brine solution. And there I'm going to decide again that x plus y equals the total. In this case, the total is 40 liters. That's how much I'm making. Then I would go with the numbers. 12% goes with the x. You don't even have to put in decimal, you can just put 12x. 16 goes with the y, and 15 goes with the 40. Notice how it's multiplied. Type it in, set it up, solve. Pretty easy. Okay, that gets us to motion problems. With motion problems, we are looking at different types of keywords. Now, you look for keywords like downstream or upstream. That would deal with water. Like the current and the speed that's helping you go faster or go slower. Or you might see something like with the wind or against the wind. Those would also kind of give you an idea of something you could be working with. Now, with downstream or with the wind, that means like it's behind you and it's pushing you along, so that adds to your speed. Upstream or against the wind, that's going against you. That's in your face kind of thing that slows you down. So that's a minus to your speed. All these are set up to where I'm saying x plus y is the x plus y is like adding to my speed. X would be like my speed, y would be the current, the water speed, the wind speed, whatever. You could also do the same thing with the minus. X, again, x is your speed, y is the current or the wind speed. Now all those, I would put those in parentheses and multiply them by how long it took, time. Okay, that should be the word time. Okay, and then I would say set that equal to the distance. So it would always be equal to the distance. Now, upstream. Upstream would be, again, x minus y times time equal to distance. Nothing very obviously difficult. So let's see an example. You can see on number 2 about Prairie Dog Creek, Gary can run whatever, can row whatever. Okay, so x would be Jerry's speed, or Gary's speed, I think it's Jerry. And y would be the current speed, the water speed. Okay, and when I say current, that's actually water speed, but we'll put here current speed. Okay, so the first thing I would want to do is x plus y and an x minus y. Okay, just write those automatically. Now, how long and how far did it take her? Time was 4. She was there for 4 hours. And she went, say, 60 kilometers. On the other one, when she was going against the current, it was 30. She traveled 36 kilometers, so that's equal to 36. And it still took her the same amount of time, 4 hours. Then you could distribute, and you would have 4x plus 4y equals 60, and 4x minus 4y equals 36. And that would be like where you could set it up, put it in your matrices, and solve. If there are any questions, please post them up to Edmodo. I'll try to answer them over the weekend. Otherwise, good luck with this. I think it's actually pretty easy. They all follow the same patterns, and you should be able to finish the packet. Okay, so that would be your assignment.